Hey everyone, today we're going to learn about exponential functions, and yeah, it should be pretty fast and easy. Let's first examine what an exponential function is, and then we're going to move into graphing them, and you'll see we're going to do some transformations like we've done before, so it should be pretty straightforward as long as you remember how to do that. So first of all, an exponential function, it's any function where the variable, the x, is in the exponent and only in the exponent. Okay, so you have your generic b to the x here. B, we call that the base. All right, and here are a few examples. You could have 3 times 2 to the x. See how the x is in the exponent, or you could even have something to 2x plus 1 power. The x is still in the exponent, and you might even recognize how we could start moving those around and graph those. But that's what we're going to learn today. So let's get started. First, I actually want you to open up Desmos. All right. And plot, you can actually type exactly that in, f of x equals b to the x. And I want you to play around with b as a slider. I want you to give us an example sketch for each of those 3 situations, when b is less than 0, when it's between 0 and 1, and when it's greater than 1. All right? And try to pick some unique examples. Don't just do 2 or 1/2 or -1. Those won't be as interesting. Pick ones that kind of encompass all the different possibilities. So you can pause it here and come back when you've got that. Alright, hopefully you graphed those. You're going to do those 3 on your own, like I said. And you're going to bring these answers to class to share with your classmates, so you hopefully will have similar answers to them. Let's talk about the Y-intercept. Hopefully you notice that it's always 1, regardless of what you do. The reason why is because, well, if you think about it, if you plug in 0 for x, then f of x equals b to the 0, and as you guys know, anything to the 0 power is 1. So that will always be, the y-intercept will always be 1 as long as you're not doing something else to the function like transforming it. Okay. I'm going to put these numbers 1 and 2 here because for domain and range, 1 and 2 follow these rules. The domain is all possible real numbers. If you think about it, there's nothing wrong with plugging a number into a power. You can plug anything in there. But the range is always greater than 0. And hopefully you noticed it's strictly greater than because we have an asymptote. So you put a little star there, you see the greater than 0. That's really important. Okay? Let's talk about graphing it. The way you want to graph it, I can make a little table of values here. Pick my good old -2 to +2. And you could do a few, 3 to the 0 power is 1, so we can plot that one. 3 to the -2 is 1/9. You can work that one out. Then just raise it to the first power and the second power, and let's just plot each of those points. You plot them all, and you notice the shape it makes. It should also look like this on Desmos if you want to plot it there as well. And just connect the dots. And some things you'll notice about exponential functions, they get really small and really big very fast. You see it gets off our graph, right after 2 there, and it gets so close to the graph it looks like it's touching the x-axis, but remember that's an asymptote, so it doesn't actually touch it. It's a good idea to go ahead and mark asymptotes as well, just so you remind yourself that those are asymptotes in the future. But yes, that's how you graph a simple exponential function. Let's graph it with the transformation of multiplying by 4 on the right here. So what I'm going to do for this, instead of plotting all the points like I did last time, I'm just going to think about what does that 4 do? And it stretches it up 4, up and vertically 4, right? Because it's on the outside, we're affecting the output. And I'm just going to remind you guys, it's away from the x-axis that this happens. Okay, so you can take each point, multiply the y value by 4, and you'll get the same thing. So I'm going to plot each point. You see the green are the original, and the orange are the new ones. So 0, 1 goes to 0, 4. 1, 3 goes to 1, 12. That's off our graph, but that's all right. And even -1, 1/3 goes to -1, 4/3. You multiply by 4. So we get those points, and we'll just connect it, and it looks very much the same. The only important thing when we're plotting it, the only difference that you really want to pay attention to is we have a new y-intercept. So see how it went from 1 to 4, which makes sense because we multiplied that by 4. Cool. You should do try the next 2 on your own. Oh yeah, and mark your asymptote. That's a good point. Do the next 2 on your own, and before coming to class again to share with the classmates, that's at the top of the back of the page. And let's go on to the next one. Feel free to pause the video and do that before you move on if you'd like. So the next one we're doing 4 to the x, very similar. We're going to do negative 2 becomes 1/16, negative 1 becomes a fourth, etc., etc. We'll plot each of these points, and again, it gets very big, even bigger, faster, because we have a larger base, right? Let's mark our asymptote again. Oh, I'll mark the asymptote here. So again, for the right side, what we want to do is we want to just think of it as transformations. We don't want to have to plot every single point, because that would be actually be kind of tricky. If you notice, anything in the power, that's next to the input. So remember, input moves stuff left and right, and it always does the opposite of what you'd expect. So by subtracting 1, we're actually moving that point 1 to the right, moving the whole function 1 to the right. And by adding 2 on the outside, that affects the output. We're moving it up 2. Okay, so move 2 up. And so what I'm going to do is each point, I'm going to take it and move it 1 right and 2 up. So we take the point 0, 1 that we plotted on the left there. The green is the old point and the red is the new point. And you move 0, 1 to 1, 3. You move 1, 4 to 2, 6, and negative 1, 1/4 to 0, 2 1/4. All right. And if you connect the dots with the red up and do that point 2, connect the dots there, you get a function that looks like it was moved right 1 and up 2, which is exactly what we wanted. Again, you can mark the asymptote there, which is a good idea to do. We'll just mark that right there. You notice because we moved up 2, the asymptote, instead of being y equals 0, it's now y equals 2. And yeah, that's how you graph exponential functions with transformations. Try these last 2 on your own again before coming to class so that you can share those with the class. And yeah, thanks for watching.